Hello! Alright, so this is the last video that I'm going to record on logarithms. Okay, so here's some word problems. This puts everything that we went over recently, just puts it all together into one. Okay, so here's some word problems. So in chemistry, you may have learned that the pH of a liquid tells you how acidic it is. So let's say that the pH of a certain fruit juice is 2.8. So the lower the number, the more acidic it is. So find the H3O+, so that's a hydronium ion concentration in moles per liter of the juice. And we're going to use this formula here. Okay? So I'm going to write that formula. So pH equals negative log 10 and then of H3O plus. Okay, I'm gonna make this a little easier so it's a little bit more manageable. Okay, so we know the pH of the fruit juice is 2.8. pH of the fruit juice is 2.8. 2.8 goes right here. I'm gonna make this a little easier. This H3O plus, let's call that X. X equals the H3O plus concentration. Okay, so what we're going to do is we're going to substitute X. So this is negative log base 10 of X. Okay, so if you guys can think of it like that. Okay, what I see here is I want to try to isolate this logarithm somehow. So in order to isolate it, if I divide both sides by negative 1, right, the negative just goes on the other side. So this is negative 2.8 equals log of 10, log base 10 of x. Log base 10 of x. Okay, now this kind of puts together what I showed you earlier, right? If you see a base here, 10, this implies that you want to rewrite this equation with bases of 10. So 10 raised to negative 2.8 equals 10 raised to log base 10 of x. Okay, running out of room here. If you guys remember, if you saw this here, so this is that formula that I showed you earlier. This is a base with a logarithmic power rule. A base with a logarithmic power rule. So this expression is just x. So I'm just rewriting this up here. 10 raised to negative 2.8 equals x. Okay, so I understand that some of you do not have calculators at home to do this. You can use Desmos. 10 raising the caret shift 6 negative 2.8. Okay, so if you do that correctly, what I got there is x is going to equal 0.00158, and that's how many moles per liter you have of the juice. Or in other words, I believe in scientific notation, you might see something like this. Whichever one works. 1, 2, 3. Yeah. So just like that. Okay. Next one. All right. So a chemist estimates that the following equation can be used to calculate the exponential decay of radium. Okay. So this is the formula that you can use. So A is the initial amount of radium. P of T is the amount of radium left after so many years, and T is number of years. Okay, so how long will it take a 50-gram sample of radium to be reduced to 5 years? So because it's being reduced, this means it's going to be exponentially decaying, right? This is our original. This is what we started with. This is what we end with. Okay, so P of T equals A times E raised to the negative 0.004 t. Okay, so what I see is A is the initial amount of radium. That's our original amount. That's how much we start with. A is 50. Our ending, so P of T is the amount of radium left after so many years. We're trying to figure out how many years it takes for it to reduce to 5 grams. P of T is 5. So we're going to substitute these in. 5 equals 50. E raised to negative 0.004 t. Okay, so what I see here is that we can divide both sides by 50. Divide both sides by 50 here. If we do 5 divided by 50 really fast, that should be 0.1. Let me double check. Yeah, 0.1. 0.1. This is E raised to the negative 0.004 t. Okay, now that we see an E here, because we see an E here, this implies that we want to take the natural logarithm of both sides. So ln of 0.1 equals ln of E raised to the negative 0.004 t. Okay. So next, what I see on the right hand side, this whole exponent here can be thrown in the front as a constant. So this is ln of 0.1 equals negative 0.004 t times ln of E. Okay, so running out of space, I'm going to erase this here. These are variables. We already took care of that. I'm going to erase it just so I have some room. Okay, so next what I see here is we can divide both sides by ln of E. We can divide both sides by ln of E, and then these two will cancel here. So what we have up here is going to be ln of 0.1 divided by ln of E equals negative 0.004 t. So if I were to just calculate that real fast, ln of 0.1 divided by ln of E. So if I do that, so it's going to be negative 2.3025. I'm just gonna 58. I'm just gonna round. This is negative 2.3028 equals negative 0.004 t. Okay. Next, in order to solve for how long it takes the 50 gram sample to be reduced to 5 grams, we need to divide both sides by negative 0.004. Okay, this cancels out, and t is going to be equal to, hold on, 258 divided by negative 0.004. So it looks like that. Okay, so when we're dividing it through, the negatives are going to cancel each other out, so it should be positive. So we are left with 575.6. In my notes I have 2.5. I put 4.5, depends how you round. It's about the same. So that's about how many years it would take. It's about 575.6 years. Okay. All right. So next one. Okay. So let's say we have Michaela. Michaela is studying the behavior of a group of cells in a lab. She starts off with 500 cells and observes that the cell population triples every hour. The function shown below models the number of cells after so many hours. Okay, so this is the function. And our goal is to find how many hours it will take for the population to reach 50,000 cells. Okay, so the reason why I want to show you this one is actually this was one of the SBA problems. So you remember in one of the, if you did quarantine assignment, the the review one. I think that's number 5 or 6. I don't remember. But anyway, I said that I took out some logarithm problems in your SBA review. This is one of the few that were taken out. Okay, now we know how to solve it. Okay, so how many hours it will take for the population to reach 50,000 cells. Okay, so what we know here is f of t is our output. That's what we're trying to find. F of t is going to be 50. We're trying to figure out how long it gets from 500 cells to 50,000. So we're going to substitute 50,000 in for f of t. So 50,000 equals 500 times 3 raised to t. Next, what I see is we want to isolate this expression here to solve for t. Divide by 500. So now we're left with 100 equals 3 raised to t. Okay, so next what I see here is, because we don't have a e here, we can take a common logarithm of both sides. So we can take the common logarithm, both sides, log of 3 raised to t. Now the right hand side here, because we have an exponent here, we can throw that in the front for logarithms. So log of 100 equals t times log of 3. Next, what we need to do is we need to isolate t by itself. So we're just going to divide by log of 3, both sides. So t is basically this expression. So log of 100 divided by log of 3. So I have that shown right there. Okay, so this is, if I round to the nearest thousand, this is about 4.192 hours. 4.192 hours. Okay. Yep. And that's pretty much it for how many hours it would take for the population to reach so many 50,000 cells. Okay. All right. So for this last problem actually came from a TikTok video. So Maria sent that to me. Thank you, Maria, for the idea. So this here is going to be based off that TikTok video. So in that TikTok video, this guy, Ludus, so this was on March 27th. He was saying that the number of people at that time had that the people that had coronavirus was 86,000, and by looking at some data, he assumed that the rate of increase goes up by about 25% per day, which is pretty high. So how many days will it take for the coronavirus to infect the entire population of the United States, which is approximately 329 million people? Okay, so we can use the exponential growth equation from quarantine assignment number 1. So it's going to be this one here. Okay, so what I see here is the number of people that had coronavirus was initially 86,000. This means A equals 86,000. Okay, next we assume that the rate of increase went up by 25. Oh, hi, it's okay. The rate of increase went up by 25% per day. 25% per day. So this is R. So this is 25 divided by 100. So this is 0.25. Okay. And we're trying to figure out how many days it takes for the coronavirus to infect the entire population. This is our output. This is f of t. F of t equals 329 million people. Okay, so what we're going to do is we're going to substitute all these things that we know into an expression. So 329 million equals 86,000 times 1 plus 0.25 raised to t. Okay. So next, what I see here is we can simplify the parentheses. So this is 329 million equals 86,000 times 1.25 raised to t. Okay, next what I see is I can divide both sides by 86,000. So if I divide both sides by 86,000, this is going to cancel. And then what we're left with, if I do this right here, this is going to be about 3,825.581. And this equals 1.25 raised to t. Okay, now there's a couple ways that you could do this. So the guy in the video here, he does it by solving using natural logarithms. You can, if you want to watch that video, it's a very quick video, and he does it using natural logarithms. What I'm going to show you instead is, because we don't have an e, we're just going to take common logarithms. Okay, so this is log of 3825.581 equals log of 1.25 raised to t. Okay. Next, what I see here is this on the right hand side. We're going to use that power property. So this t is going to be placed in the front. Okay, so this is log of 3825.581 equals t times log of 1.25. Okay, next what we need to do is we need to solve for t. So in order to isolate t by itself, we need to divide both sides by log of 1.25. Log of 1.25. This will cancel out with this, and we're left with t, and we have to go ahead and calculate that there. So this is going to be log of 3825.581 divided by log of 1.25. So see that right there. So just calculating that. This means our time, our units are in days because 25% per day. So our time is going to be in units of days. 36.97 days. So what that means is that it's about 37 days. So if you guys saw that, if we didn't social distance at all, then 37 days later after March 27th, that means if we didn't social distance, then our entire population would be infected with coronavirus by May 3rd. That would be pretty crazy. But it seems like social distancing is working, and I'm glad that it is, and we can continue to keep flattening the curve. Okay, right. And that is pretty much it. Let me know if you have any questions. If you want to look at this video is in Google Classroom, the notes. Okay. Other than that, that is the last video on logarithms. Woohoo! And let me know if you have any questions. Okay, bye.